Hello, GAC. It's Coach Johnson. We're with Pre-Cal 12 right now. We're about ready to look at Section 2.7a on Cyber Day. And so as we get started, we're going to hop right on into it. Make sure you take a look at the schedule that's on Haiku for this Monday for Cyber Day. Again, if you have any questions, please let me know. Other than that, let's get it underway. Again, Section 2.7a. Make sure also, as I put this over, a couple things that you might need to know. First off, it's very important to note that the first 5 problems will be due on Tuesday when you come in, and basically it's just to make sure that you did something over Cyber Day, and it'll be just a little homework grade. You will still have to turn those 5 in, so you're gonna have to do them anyway. I'm just trying to get you to do a little earlier so you have an idea of what you're doing when you come in on Tuesday. All right, let's begin. First thing to note is that when we graph a rational expression, we have certain steps that are taken in order to solve for it. Now, you could follow all of these steps, and you may even want to take a screenshot of all of this, but the reality is that it doesn't necessarily matter what order it is. Sometimes it does matter what order some of the stuff is in, but for us today, we're not going to worry about it. There's a couple things we really want to focus on. First thing is we want to find the x and the y-intercepts. We want to find the horizontal asymptote. We want to find the vertical asymptote. And if we have a hole, let's find the hole as well. Sometimes also we may have a slant asymptote, and we'll look at that today as well as to how we graph that in situations where that comes into play. All right, you ready to go? Let's get this going. All right, I'm going to actually delete that. There you go. All right. Now, as we begin, the important thing to note, like on number 15, is that we first want to solve for both the top and bottom, actually not solve, I'm sorry, factor both the top and bottom by simplifying. So we should have x plus 2 and x minus 2 on the bottom, and we've got that underway. Now, if there's something on top and bottom we can cancel, we're going to do that next. But as we can see here, there's nothing in this place that can cancel, so we're going to leave that as nothing. Since there's nothing that cancels, we know that there will be no holes there, because that's the only time that if I would cancel on top and bottom, that's the only time we'd have a hole. Now, as far as the x and y intercepts, remember the y-intercepts is when we plug 0 in for x. So if I were to plug in for the original 0 in for x, we'd have 0 squared all over 0 squared minus 4. Well, on the top we'd get 0. Well, on the bottom we get negative 4. 0 over negative 4 just gets me 0. So hence we have 0 as a y-intercept. And again, we put it in as a point. We do the same for the x-intercept as well. Now, as I come to the x-intercept, we plug 0 in for y, or f of x. So we would get 0 equals 0, or I'm sorry, apologize, plug 0 in for y there. So then we have 0 equals x squared over x plus 2, x minus 2. Well, like we showed in class over the last few days, really when we're talking about this, we can multiply by x plus 2, x minus 2 by both sides to cancel it out, because anything times 0 is a 0. To where 0 equals x squared. So if I square rooted x, the only thing x would be equal to is 0. So we would say, just like with the y-intercept, 0, 0 is our x-intercept. All right? Now come back up over here. We're going to come over to their original here. And what we're going to do is we're going to find out what our vertical asymptote is. Remember, the vertical asymptote is what makes it undefined. So again, if it's canceled and it's a hole, remember it can't be a VA. It can't be an x-intercept. So the important thing to understand is that if it's here, we set both equal to 0 to see what makes the bottom equal to 0. Well, as we notice that, we know x would then be equal to both 2 and negative 2. So when we do that, we have 2 and negative 2, x is equal, and we can leave it as is there. So now my horizontal, we can come back to our original. We know we have a degree of 2 on the top and a degree of 2 of the bottom. So we could actually divide x squared over x squared to give me a y-intercept, or I mean a horizontal intercept of y equals 1. Remember, horizontal is left to right, vertical is up and down. And since we have a horizontal, remember we have none for our slant. Remember, slant is when we have 1 degree higher on the top than the bottom, and that's where we would divide it out. So now what I'm going to do is I'm going to do this in red. We know we've got an x and y intercept at 0. We know we've got a horizontal at 1. So I'm going to kind of go across as best as I know I can there. The vertical will be at 2. There we go. And -2. Okay, so we've got that there. It's perfect. No holes. We've got that. So we got everything here. The only thing that we're missing right now is what is occurring on this graph. So what we want to do is we want to plug in a point here, here, and here to see what we get out. So what we're going to do is on the side, we're going to plug in, let's say 1. Plug in 1 there. We'll plug in 3. That'll be good. And we'll plug in -3. All right. We're going to plug those values in and let's see what we get out. So we have 1 squared over 1 squared minus 4. So that'd be 1 over -3. So it'd be -1/3. Okay, is that 1? Now let's go back to 3. 3 squared is 9. 3 squared is 9. 9 over 9 minus 4. So 9 over 5 is what would be here. So you could say 9 over 5. You could also say 1.8. You could say, but we'll just say 9 over 5. And also note, since it's negative, even though you're plugging a negative in, if it's squared, it's still going to produce a positive. So you're going to get the same thing, 9 over 5 at -3. Okay? So let's go to 3 here. 3 would be at 9 over 5, so that's about right there. And -3 would be at about 9 over 5, which would be there. So this thing is going to rise. Remember, you can't cross that horizontal there. It's going to kind of go this way. And same holds true here. It's going to approach it, and it's not going to cross it. You could plug more values in just to make sure, but that's kind of the idea. And then 1 -1/3 would be there. And I'd like to do something. Let's plug in 1 here. I'm not sure what happens right here. Let's see what happens. I mean -1. So -1. As I look at that, I notice that, oh yeah, it's actually going to be the same thing because if I plug it in, so it should be about right in there. So this thing's going to look like a parabola almost because it both falls left and to the right. So just like 1 and -1 would be -1/3 as well. And so right there, that would be my answer for number 15. All right, let's go to another one. I think a lot of these are just kind of using it and just practicing it. Let's look at number 30. All right, so let's go VA, HA. I always put all of these down because that just helps me understand that. All right, all 6 of these. We may not have all of them, but we're going to put them all down anyway just to be sure. All right, vertical asymptote. Well, first off, we factored. Check 1. We're done with that. Check 2. What makes the bottom equal? Well, first of all, can I cancel? No, I can't. So we're going to have none for our holes. Next, for our VA, I set the bottom equal to 0. When I do, x will be equal to 3. Remember, for our horizontal, we know we have a degree of 1 on top, degree of 1 on bottom. So we divide it out. X over x gets me 1. So y equals 1 is my horizontal. Now, once I plug in, this is kind of the stuff that a lot of people struggle with for some reason. We'll just forget. Remember, with y-intercept, we plug 0 in for x. Okay, so we're just going to plug in. 0 minus 2 is -2. 0 minus 3 is -3. So 2/3 is my y-intercept. So that means in a point, 2/3 is my y, where 0 would be my x in that situation. Okay? All right. Remember, too, since we have a horizontal, we're going to have none for my slant. So we'll just keep that there. All right. Next we have, let's plug 0 in for y, which will get us our x-intercept. Remember, if I multiply by x minus 3 by both sides, I'll show it just so you know. Anything times 0 is 0. So it's really, we just set the top equal to 0 and we know that that would be x equals 2. So our x-intercept is 2, 0, and we'll plug that in. So now we've got everything here on our list. We have 2, 0. We have 0, 2/3. Okay, so we'll put that there. And our y is going to be equal to 1, or our horizontal is going to be y equals 1, right above that y-intercept. And x equals 3 should be right here. All right. Remember, we're going to stay in that spot there, right? So this should go here. It's going to kind of connect the dots here. But remember, it's approaching it, but it's not going to cross. So it should go somewhere down there. I know it's not perfect, but you get the idea. And this goes kind of kind of towards the left there. Remember what's over on this side, we could plug one in just to be sure, but I think we're going to be reflected over in here. Remember, no symmetry here because you can't reflect it on the y-axis or the origin. But if this was squared up here, then it would be over the origin, but it's not. So let's just plug in 4 here just to see what happens for our x and y. And this is just to be sure. 4 minus 2 is 2. 4 minus 3 is 1. So 2 over 1 is 2. So we have 4 comma 2. We sure do. And again, just like before on that side, we graph it and we are done. Again, all of these things are kind of the key, or the glue rather, that holds everything together. All right, let me erase this. You could always go back in this podcast if you're struggling with that. Let's go through everything again, except this time let's start with this first one. F of x equals x to the third minus 3x squared all over x squared minus 1. Again, the first thing that I always do is I always factor. So I'm going to take out an x squared on top, leaving me with x minus 3 on the bottom. Notice on the bottom, when I factor, I'll get x plus 1 and x minus 1. All right? So I have everything right there factored out. Now, just like before, VA, HA, you know the drill, x-intercepts and y-intercept, and holes, and last but not least, the slant asymptote if we have that. All right? So vertical asymptote first. Nothing cancels, so we have no holes. Okay, none. We set the bottom equal to 0 to see where it's undefined to get our VAs. So x would be equal to 1 and negative 1. Okay? Remember, those are lines, right? Those go up and down. So I'll put those in right now just so you can see it. So those go up and down right here. All right, it's going to look a little funky, but that's okay. Our horizontal, well, if it's greater on the top than the bottom, we're going to have none, right? So we have none there. But remember also, if it's greater on the top than the bottom by 1, we will have a slant asymptote. So what we need to do is divide the bottom into the top. So what I'm going to do right now is I'm going to put it over on this side. I'm going to take x to the third minus 3x squared plus 0x plus 0. And I'm going to divide that out by what was on bottom, x squared minus 1. Well, in the slant asymptote, we ask ourselves, what times x squared gets me x to the third? Well, the answer would be x, right? Because if I then distributed it, it would be x cubed minus, well, actually, you know what I needed to do? I needed to have 0x minus 1, right? Forgot to put that 0x. So now 0x times 0x is 0x squared. And x times negative 1 is negative x. And so that helps us a little bit to where now I change the sign to where that's gone. And now I've got negative 3x squared plus x as my answer. And I can bring down the 0 if I want to. So my question now is, what times x squared gets me negative 3x squared? And that would be negative 3. So I distribute out negative 3x squared minus 0x plus 3. Now I could keep going because my answer would give me my remainder, right? Because I brought everything down. But the remainder we're not even concerned with. What we're concerned with is that x minus 3. So what we're going to do is we're just going to put y equals x minus 3 right there. And what that does is that's the slant asymptote that helps us within our graph. So if I were to graph this, again, we have our verticals real quick. Okay? We know that x minus 3 has a y-intercept at negative 3. And then rise over 1 is 1, 1, 1, 1, right? And so you could keep going and going. But the idea is that there's going to be a slant asymptote that comes across something like that. So on my vertical and my slant, notice there is no HA, so I don't have to actually do that one there. Now, finally, I need to do my x and y intercept. With y-intercept, I'm plugging 0 in for x, to where if I did that, I get 0 minus 0 all over 0 minus 1. So I get 0 over negative 1, which would be 0. So my y-intercept is going to be 0, 0. Just like before, for my x-intercept, I plug 0 in for y, to where this equation would be equal to 0. Remember, we can eliminate the bottom, to where I set x squared equals 0 and x minus 3 equals 0. So my two x-intercepts would be 0 and 3. So I get 0, 0, and 3, 0. And what we have now is we have our x and y intercept, one at 0, 0, and one at 3, 0. Okay? Alrighty. Now, one other thing that you might want to note is that when we graph this one especially, is that we would really desire, what we're trying to do now is trying to plug in for my x, right? What value is plugged in for x? So let's plug in 2, because I need one here. Let's plug in, you know what? I'm going to graph it because I could plug in 1/2 and get that out. I guess, you could put in 1/2, but I'm going to go to my table on that one. But then I'm also going to plug in -2, okay? Now, on your test, you will, with some of these harder ones, have a calculator to back up what work you show. And so just to be sure that I'm on pace here, I'm gonna plug in x squared. I'm going to plug this in, x squared times x minus 3. And then I'm going to divide that by parenthesis x squared minus 1, all right? X squared minus 1. All right. See what graph it comes up with. And looking at it, trying to see here. There we are. Okay. As I look at this, I notice it gets a little bit funky here. And I'll show you why here in a second. But let's plug in 2 real fast, and then I'll show you where we're at, okay? First of all, the middle part, we could plug in 1/2, but it's going to look like a little parabola here, okay? Again, I don't, as I looked at the test, there's not going to be one that's this tricky. Big thing is understanding how to solve for this, and the ones that are a little bit simpler, like the other ones, we'll have to graph. But let's continue just for good practice, okay? So plug in 2 here. 2 cubed would be 8 minus 2 squared would be 4. 4 times -3 is -12, so we have 8 minus 12 there. On the bottom, we get 2 squared, which is 4. 4 minus 1 is 3. So when we do that, we get -4 over 3 when I plug in. So it should be like right in here. So what happens is this graph is going to stay in this region. It's going to go down there. It's also going to go up in this direction. Now, if I plug in -2, let's see what we get. -2 cubed would be -8. -2 squared is 4. 4 times -3 is -12. Okay, so we got that there. -2 squared is 4. Minus 1 is 3. So I got -20 over 3, which would be the same as like -6.6. So if I go here, 1, 2, 3, 4, 5, 6, -6.6 should be in about that direction, which if I were to do this now, the graph would be in this region, which would hug here, which would ultimately give me my answer. All right? Alrighty, so again, that is what we're looking at here. I would like for you to do the first 5 on your homework. We'll look at that a little bit later. You notice that as we went through these, that we went step by step, found all 6 things, and used those 6 to graph it. Again, use your calculator sparingly. Note that a lot of the tougher ones, like the one I just did, the third one, is one that you'll have some backup on with the calculator, whereas ones like this, we should be able to do by hand. All right. Spartans, thank you so much for today. This was Coach Johnson. And again, if there's anything I can do to be of help to you, please let me know. I'm always here for you. And we'll touch base with you on Tuesday. All right. See y'all. Bye.